Hey friends, this is Derek from TCI, and it's another beautiful day in our city. I hope that I'm seeing what you're seeing when we look at these beautiful buildings. That's right, it's networks everywhere. One for every tower, one for every floor in every tower, and every tenant space on every floor. Today, you and I are going to make another one. Let me introduce you to our job site. This is currently still under construction, and we're here to get some Ethernet in place. We're going to be building this entire network from scratch. There's no existing cabling and no existing network infrastructure of any kind. We'll be building a 4-post rack, about 115 or so wires, give or take, and then we are going to terminate everything and drag all the cables. This will be a bit of a training video, so let's follow along and get started. When my colleagues and I arrive on site for the first time, what we're mainly interested in is figuring out how to get from the server area through the ceiling to all the various locations where we need Ethernet and data outlets. It's important to look in the ceiling, lift the tiles, and work out your pathway for how you're going to drag these cables. Because this is a construction site, I do need to check with the general contractor and make sure that there's not any plumbing, fire alarm, fire suppression, or electrical or HVAC stuff that's going to be in the ceiling where I plan to go. I need to coordinate with all the other trades to make sure I'm not causing any problems while I work out my pathway here. Here's where our rack is going to be installed. The contractor has installed plywood on the wall to give me a strong surface where I can anchor all of my necessary supports for my rack. While we're in this area, we're going to explore the ceiling and see what the conditions are. This is Chase. Chase is up here checking out what kind of obstacles are in our way and working out the best place to put our cable supports. Once Chase works out the best places to place cable supports, we're going to use a Hilti concrete nailer to lock in our various hangers and J-hooks and other supporting mechanisms into the concrete ceiling. It's important, at least in the state of Hawaii, that all of your network cables be independently supported by their own hangers. You don't want to zip tie or Velcro to other people's fixtures. Plumbing, EMT, and other items are off limits for us. This is a permitted job, so we have to follow the rules of the NEC to the letter. The most common support that we use is a batwing J-hook. These things come in various sizes for various sized bundles of cable. A little one like this is all that we need. You flex the wings in order to bend them around this threaded rod that we anchored earlier, and then it will easily support the Ethernet cable weight as we pull. These typically are installed down hallways or over offices in as straight a line as we can manage. This is Jeff. While me and Chase are working out the J-hook path for our future cable, Jeff will be building the 4-post rack. The rack that we are using today is an ICC brand. I'm not married to any particular piece of hardware. You can use anything that you like, from Chatsworth to Panduit to ICC. They're all really great products. But in terms of giving you advice on how to build them, they're all very, very unique and different. The best advice I can give you is while you're assembling your rack, try and make things only finger tight. Don't crank them down as hard as you can at the start. You'll need to make sure that you're level, squared up, and then slowly start to tighten everything as you go along. As you can see here, there's a lot of little areas where you could get things out of alignment. Having them finger tight allows you to fix it without having to undo your hard work. We oftentimes lay the rack on its side in order to assemble it, but it's important to carefully measure out the height of this rack and make sure that your plywood that's on the wall to support its weight will in fact match. Jeff is demonstrating doing each screw one by one, not fully cranking it down, but tightening them slowly in order. He's going around the rack more than once in order to tighten them more and more as he goes. That way, he can be sure that he stays in alignment as the screws come to their full tightness. Once you're happy with the level and squareness of your rack, you can slide it into position. We're going to give Jeff a hand with this real quick, and then he's going to move on to his next task. With Jeff finishing up the rack and getting it into position in the server room, me and Chase will begin to pull our various Ethernet. We do this first by getting a ton of boxes ready. We'll stack them up in a group of at least 12. 12 is the minimum that I like to pull when I'm on a big job. That means 2 pulls and I've got a whole panel I can fill immediately. I'm going to show you 2 different methods to distribute your wires. The first way I'm going to show you, especially because this is a busy work site and I can't work over the other tradesmen while they're in my way, is I'm going to distribute my Cat6 boxes to the areas where the outlets they will feed are located. So each of these offices has between 1 and 2 and 3 data outlets within them. I'll lay that many boxes near each of their doorways. With my boxes distributed, I'll start at the furthest end. I always start as far away from the server room as possible so that the hardest pulls I have to do are done first. Don't save those for last. I will then use the available marking space on these boxes to label these cables. I will also label the cable itself. It's not important what I label it, so much as I'm following along with my own pattern. These Sharpie marks are not for the customer. Never do that. Always print out your labels and stick them directly to the cable when it's time for the customer to get the finished product. But while you're pulling, you can use Sharpie just for your own reference. Now you've seen me speak in other videos about this extending rod. Now you're going to get to see it in action. First up, I'm going to attach via electrical tape the first few boxes of cable to this rod. I'm then going to climb the ladder with the rod in my hand, extend it to its maximum range, and then move my ladder over several ceiling tiles. Catch that rod, bring it forward, pulling the cables with me, and then I'm going to attach the next set of cables. As I go down the hallway, I will eventually collect a cable from every single box and be pulling them all at once towards the server room. Before I continue, this is an important sidebar. This extending rod is made of metal. In other videos, you've seen me use this voltage sensor to determine if any wires that I come across are energized or not. If the voltage sensor turns red, I'll need to ask the electrician to turn off this circuit. And if they're unable to do that for any reason, I need to go around this J-box. That way, I don't risk anybody getting shocked. Always work with safety first and foremost on your mind. As I work my way with the rod down this hallway and attach each of the Cat6 boxes to the handle of the rod, it will gain some weight, but it should be possible for a single person to pull about 12 boxes without too much difficulty. If you're really strong, you could probably get away with a full 24. But for me, 12 is where I like to stop. I'm not trying to wear myself out on this job. So here's what it looks like as I have all of the boxes connected up to my rod, pulling them all at once down the hallway. Eventually, I'll need assistance from Jeff. As I get all of the cable towards him, he can then from the ground pull and get everything lengthed out so that it can reach the server room. Because the server room is not ready right away, we're going to roll up the Cat6 that we've got so far and stash it in the ceiling until the other tradespeople are out of the way, done with their tasks, and then we'll bring this down again and feed it into the server room when the site is clear. Now that's method number 1. Here's method number 2. I'm going to install a nylon string down that same pathway that I previously drug those Ethernet cables. That nylon string will go through the ceiling. I'll tie a loop to it, and then I'm going to leave a lot of slack. With my cables, I will attach them all to that loop. I'll go to the other end of the hallway, and I'm going to pull on that nylon string. All 12 boxes will feed out at once, and before you know it, you've got 24 wires down this hallway, and it's no problem at all. Much easier than the method I just showed you. I'm going to repeat that process by strategically placing my cable box system wherever I can at the far extremes of this floor plan. That way, I get all the furthest ones done first, and at the very end of the job, when I'm the most tired, only the shortest things need to be run. With 12 to 24 boxes, you can quickly hit the entire floor plan and cover this entire space. We call this roughing it in. Nothing's terminated, but the wires are more or less where they need to be in the ceiling above their targets. We've been keeping a map of our progress so that our teams can work in tandem, each person on a different side of the map, running it all in. And when we're finished, boy, that's a mess. We got a lot of cables that we're going to be sorting through. We'll break there for the day, and on our next visit, the sorting begins. Our primary sorting tool is the cable comb. The cable comb that we use is meant for 24 cables, Cat 6 diameter. All you have to do is lay all the cables into this honeycomb shape and then slowly pull it down, untangling as you go and Velcroing every so many inches. We've settled on a 12-inch Velcro strategy, and we're just going to go ahead and pull this through. This is Kaysen's first time doing any kind of cable combing. If he can do it, so can you. It's not hard. If you don't have a cable comb, don't worry about it. All you really need is the Velcro. Just take special care and time, untangle this mess, one thing at a time, pull your Velcro down and tighten it up as you go, and then cut a new strip and continue to straighten out these wires. Anybody can do it, and you don't need a special tool. The tool is just one of those nice things to have that speeds you up a little bit. With the cables somewhat organized, it's time to figure out a way to get them down out of that ceiling and into our rack. This ceiling interface system that I will be using rests on top of our drop tiles. We're going to break out our jab saw and cut a hole in the tile that matches where this metal outlet has a hole in it. We will then, after that's done, go and get one of our riser tubes out of the box, and that will screw in from the bottom and the top and sort of lock in and create a grommet or pathway from our ceiling towards our rack. This creates a clean ceiling entry look that looks very professional. The one consideration is that there cannot be any weight placed upon this riser tube, so you must suspend your cables very carefully and securely in the ceiling above. Before we bring any of the cables down from the ceiling, we're going to open up our cable ladder box and get this thing into position. We need it in order to give the cables something to rest on while they're above the rack. I'm going to lay the cable ladder on top of my rack and get a good measurement of what I think the length I need is. It comes in a 10-foot segment, so I'm going to need to cut it down in order to get it to the appropriate length for this rack. In order to cut it down, I'm going to use a bandsaw to just real quickly cut through each side. Once I have made the cuts in the ladder, I will then cover them up with this piece of silicone so that the edges are not sharp, and then I will lay it back on top of my server rack. I'll use the included J-bolts to lock it very sturdily to this plywood, and then I will use a top plate adapter that ICC provides for this model of rack to firmly lock the ladder tray to the top of my server rack. I just have one more thing to do before we can bring the cables down. We're going to need to break out our masonry drill and put a hole in the floor so that we can screw this rack directly to the floor, preventing it from moving while I manipulate the cables. I always make sure to drill extra deep for these. Tapcons require a good amount of depth. In order to be sure the holes are clear of dust so that the Tapcons don't get hung up in there, I'll bring out my vacuum and try to clean out these holes after I've drilled them. I'll sink some Tapcons so that the rack won't move, and finally, we can begin the process of bringing these cables down from the ceiling into the rack. I had Jeff, Chase, and Kaysen organize the wires in groups of 24, and they're in numerical order. I'm going to bring them down in a specific order so that I can stack them nicely. I'm just going to go ahead and speed through this portion for you. As you watch me speed through this, notice that I'm targeting the left side of my cable ladder because I'm trying to target the left side of my future patch panels. There is a little bit of a method to my madness here. This is a pretty good start. You can see the cables on the ladder as they'll start to look later. However, this is not all of my cables. If you've been eagle-eyed throughout this video, you've noticed in the bottom left-hand side of my screen that the electrician has occasionally been adding to this section here. These pipes represent areas where the cables are going to come up from underneath of the floor. So for certain cubicles, conference room tables, etc., the cables will go through these pipes. In order to get these onto our rack, I'm going to bring them straight up the plywood and attach them to the cable tray from the rear and then have them join these bundles. To do that, I'm going to install some zip ties directly into the plywood. However, these are purely for strain relief and structural support. They're not very tight. I'm still using Velcro to maintain control of my wires. Velcro is much better because you can undo it and then reapply it. There's a little bit of danger when you cut a zip tie that you might snip into the jacket of the cable. There's also the ever-present danger of making a razor-sharp edge when you cut it. That's why these flush cutters are important. When you trim your zip ties, they won't be able to get even with you and cut you later. The patch panels that we're going to be using on our rack are these simple TrendNet unloaded 48-port 2U panels. There's nothing fancy to these. I just like to use ones that are empty so that I can terminate onto a jack and then plug it in directly into the rear of this panel. All of these wires that I have here on the ground are going to be roughed into these 3 panels that we've got showing here in the rack. To help me with the weight of these cables as I rough them into the panels, I'm going to be using these rear supports from ICC. These are generic and will fit any kind of panel that I happen to purchase. The method that I use to rough these in, as you may have seen me do in other videos, is to separate the cables out numerically and then place them through the unloaded port that they're going to be terminated into. When I'm doing my rough-in, I always start with the highest numbered cables and the lowest panel. That way, if I run into any problems, I'll know immediately that my cables are not long enough or that there's some other issue with the routing of the cables, and I have time to fix it. I don't want to find out at the very end that the thing I needed to work the hardest to reach, down at the bottom, has some kind of issue that causes me to undo work up above. So I always start with that lowest panel. Once I have everything roughed in, I then use the rear supports to help me with the weight and cable management. I'm always using Velcro here, as you can see, because I don't like the way that the zip ties crush down my wires. I'm showing here that I've brought the cables in on the left side of the rear support and the panel, and as I bring more things through for the rough-in, I'll start edging my way over to the right side of the rear support. I don't like the cables hanging or drooping, and I'm really concerned about not having room for my switch. So I like to keep these real tight. That's what the rear support is really helping me with here. After I'm happy with the Velcro at the rear supports, I'll begin to Velcro my way backwards along the combed section of my Cat 6 bundle. I'm sure I don't have to tell you that all these Velcros need to be aligned. What would we be doing if we weren't making this look completely uniform? Come on now. Once I have the panels sufficiently roughed in and Velcroed nice and tight, I'll go through and bring the labels forward with my Sharpie. Sometimes I have to take a break between terminating panels, and I don't want another person to knock my cables out of their holes, and then I won't remember where they go. So I Velcro them just to give it a little bit of security and another set of labels just so I don't forget. With that, it is time to terminate. We are going to be using these jacks here, which can be crimped with an all-in-one tool. I like these a lot because their teeth are angled at 45 degrees, which makes it possible to work just a little bit faster. You can see Jeff here as he begins to terminate. With each termination, Jeff is able to insert the jack right into the back of the panel, and it's good to go. If you happen to have a colleague like me available, each person can work on one side of the panel, and you can terminate towards the middle. I'm going to show you here on the back of the rack how it looks after we've terminated, and we've tried to make more use of that rear support. If this is your first time just getting this far, you're already way ahead of the game. We're almost to the last panel, so we're going to break here for the day. However, I want to draw your eye to the way that we've laid the cable bundles out. We affectionately refer to this as the waterfall. This is where all the cable bundles come down from the cable tray and enter the back of the panels. Make sure that you keep your Velcro aligned, super important, but also try and stack your cables in a way that's sustainable in case you need to add some more later. It's a new day here on the job site, and the internet provider has dropped their fiber circuit. According to plan, it's going to go at the very top rack unit. The firewall is meant to go directly below it. To support this, we have a shelf set up. Seems like as good a time as any to get it installed. We'll drop that into position, and then in the gaps between the panels, we may as well put in the cable managers. We'll be using these Neat Patch 2U cable management cartridges. When it comes to managing all of the patch cords from your switches to your panel, there's a whole lot of ways you could handle the situation. For those of you who are very experienced, I'm sure I'm going to hear about it in the YouTube comments that I could have done this a lot better. To complement those horizontal managers, we'll also be installing today a vertical manager. This one is from Fiberstore, and it requires just a little bit of assembly. It goes on the rear of our rack, and it is split into two channels, front and back. There's a door that swings open, which makes access to the cables within it much simpler. I'm going to utilize the front section for power cords and the rear section for server-to-server connections or switch-to-switch connections, or if anything gets mounted on this plywood in the rear, it will enter this cable manager, then go up to the cable ladder above, and then down into the horizontal managers via their rear entries. The vertical manager is one of those things that is nice to have, but not absolutely necessary. Therefore, I'm only going to install one. But if you were dealing with a lot of cables, you could install one on each of the corners, and you would be really well set up for cable management. I don't think it's necessary, but you can make your own choices. One of the final portions of this rack that I'll be installing are these cable support rods. You probably noticed that our cable waterfall has gotten a little high and is really not very sturdy. These rods give us something to tie to so that the waterfall system maintains its shape. With all of those components installed, we now have a rack that's ready for the technology team to come and start loading their equipment. It will primarily be the firewall, switches, and a battery system. Before I hand everything over to the IT staff, I'm going to leave behind some patch cords and extra screws and things like that inside of the cable management cartridges. Here's one of the unsung heroes of technology right now. Under my watchful eye, switches are getting installed and patch cords are getting attached. You can see here how we thread those patch cords through the cable manager in order to keep things nice and neat. I think you'll agree that the final product looks really good. It does take a little bit of forethought and some planning and a lot of practice to get to this stage. But if you've been following along, you'll see that it's not so bad. A series of discrete steps that you can individually master, and when you put them all together, you end up with a beautiful final product. You might think that we're going to wrap up the video there, but we're not. Some of the more experienced viewers are probably already got their comment box out asking me why we haven't tested these cables. Well, that's because we're going to do it right now. To do our testing, we're going to use this Fluke tester, and what the process is to load the remotes into the panels and then go around and check every single one of these wires and make sure that there are no mistakes in our terminations. I'll let the device confirm that each of my wires is good to go. It has a memory inside it that can save the results, and with that, I can print a report later for the end users to review. As we go around and confirm that each of these items is good, we'll also take the time to label it. It would have been smart of me to use an Avery label and print out all the labels at once, but what can I say? I didn't think of it until I was on my hands and knees under these desks for the 55th time printing yet another label. Nobody's perfect. Everything is now online and operational, and we're about to leave here. However, there's one more important thing that we need to talk about, and that's a quick safety sidebar. One of the things that I'm sure a lot of the older engineers are wondering if I did or didn't do is, did I ground this rack? The answer is yes. And if you've got a rack like mine, you'll probably want to connect it to a grounding plate, such as this one shown that my electrician installed for me. He also generously left behind a couple of lugs for me to tie into. A grounding bar is necessary because foreign voltage that might land on my Cat6 wires will allow electricity to traverse to areas that it was unexpected. It can cause burns, fires, and injury. It's important to use the grounding bar to make a connection to your server rack. I'm going to use this tap kit in order to put a threaded bolt right through one of the normal screw holes on my rack. That will wear away the paint, which is also pretty important. The paint has higher resistance than the metal underneath, and I want to give electricity the easiest path it can get to ground. It's good practice wherever there are two painted pieces touching each other to take a wire brush and wear away the paint so that the metal contacts directly. This will give electricity the quickest path to ground and trip a breaker circuit before any kind of fire can break out. It's really rare, really unlikely, but you don't want to put all this hard work into your network only to watch someone get hurt by it. And with that, my friends, we are done. I'm going to stay behind just a little while, look out the window, and daydream of all the networks yet to build. See you again in the next one.